Hello everyone, so this video is a direct follow-up to the previous one on how to install CodeSaturn with Docker. If you haven't watched it already, a link is in the description. We are now going to use this Docker installation of CodeSaturn to showcase a basic von Karman vortex study. We'll first use a Docker image of Salome to create the geometry and the mesh, then move in the CodeSaturn Docker and run the study. Finally, I'll show you how to post-process the result on ParaView properly. So first, let's open Salome with the Docker container. For this video, we're going to go into the geometry module. We'll start by creating a rectangle. As we are going to do a 2D study, this rectangle will be a plate, so we don't really care about the dimension along Z. Let's put it to 0.1. The other two dimensions are going to be 2.2 and 0.41. Let's apply and close. Now we don't really see the box, so let's zoom a little bit. I remind you that if you want to zoom, you can press Ctrl and left click, and if you want to rotate, you can press Ctrl and right click. Ctrl and middle click will allow you to span in the 2D plane the picture. Now we are going to generate a cylinder that will act as our main obstacle. As a radius, we'll put 0.05, and the height we don't care about it, as it's going to be 2D at the end of the day. Apply and close. Let's now translate this rectangle like that to put it in the middle of the plate. Apply and close. Now we're going to perform a cut with the following button, and we'll select as the main object the box, that is going to be the flow, and as a tool object, the translated cylinder. Now you see the cylinder disappeared, and now we have a hole where the cylinder was before. Now, in order to make things easier for the meshing algorithm, we are going to intersect this flow with some planes. Let us start by creating 2 points. The first point is going to be at the following coordinates, which corresponds roughly to the center of the obstacle. You can see it here. The second point is going to be at the following coordinates, and you should see it here. Now let's create the planes. Use this tool to generate planes, and as a first plane, you're going to select the point in the middle of the obstacle, vertex 1, and this vector along Y. It will create you a first plane. We don't need it to be so big. Put it to, for instance, 6. But check, if you unzoom, that it's cutting your whole geometry. Now you can press apply, and we're going to generate other planes. The second plane is also going to go through the first point, but this time it's going to be orthogonal to this vector. Apply. Now the third plane is going to go through vertex 2 and be orthogonal to this vector. Apply. Now we're going to generate planes with 3 points. Let's move a little bit the view on this side. As the first point, we're going to select the first vertex again. But now, as a second and third point, we are selecting these two. And finally, let's do the same on the other diagonal of the rectangle, there. Apply and close. So it looks messy, but at the end of the day, what you should observe if you're looking at the thing from a top view by clicking on this button is that the plane should cut the mesh in this way. Now we are doing all of these planes in order to create a partition. Go in the partition tool and select as the object the cut. And as a tool object, select all of the planes we just created. Apply and close. Now you can see that the geometry for the flow has the obstacle but also some planes lines. They are going to be useful for the meshing algorithm later. But before moving to the meshing algorithm, we're gonna create some geometric groups. Go in the menu and rename the partition as flow, as this is going to be the geometry of the flow. Now you can right-click and select Create Group. We are going to create several groups. Let's start with the inlet. So this is where the water is going to come inside the mesh. Add. Apply. Similarly, we are going to create an outlet. This is where the water is going to leave the mesh after it flowed. And we are selecting these two faces. Let's add them and apply. Now we're going to create some symmetry groups. As the geometry is 2D, we don't really care about these two faces, so we're going to define them in Code Saturn as symmetries. To select several faces this way, you should press Shift plus left click. Now go on the other side and pick all of the faces here too. Once you're done, select Add. You should get, at the end, 20 faces. If you did any mistakes, like I did here, if you want to add faces to a group, you can click on the group here, right-click it, go in Edit Group, and then you can add like this. Finally, we're going to create a last surface group that is going to be the walls of the flow. Select the sides. You should have 6 faces for the sides. And do not forget to now add the obstacle. Apply. Now finally, we are going to create a 1D group made of all of the vertices that are along the z-axis. Let's name it z-vertices. Do the same along the x direction. This group is going to be useful when we'll be doing the mesh. At the end of the day, you should have the following groups: the inlet, the outlet, the symmetry group that are basically the planes orthogonal to Z, and finally the walls. If you make everything else invisible, the walls should just be the lateral side as well as the obstacle. Now let's move to the mesh module. Create mesh button. As an algorithm, we're going to select the hexahedron algorithm. Then we'll move on to 2D and impose a quadrangle mapping algorithm so that we have 2D quadrilateral elements on the surface. We create a new hypothesis, quadrangle parameter, and select quadrangle preference, and move into 1D. And we're going to impose a wire discretization algorithm with the hypothesis number of segments set to 30. At this stage, if you right-click on the mesh you just created and go on Compute, you're going to see that you have a much finer mesh around the hole than elsewhere. Second thing you'll notice is in 3D, along the z-axis, you have much more elements than what you want. We need only one element along Z. We are now going to create submeshes to solve these issues. Right-click on the mesh you just created and go on Create Submesh. Here, we'll select the Z-edges geometry group and impose a new 1D wire discretization algorithm. Go into hypothesis and create a new number of segment hypothesis, and this time you can set it to 1. This way, we'll impose only one element along the Z-axis. You can clear and compute the mesh, and as you can see now, there is only one cell along the Z-axis. Finally, let's make a final mesh after the obstacle. Create a second submesh, and this time select the X edges. Add another wire discretization algorithm and another set of hypotheses, number of segments, and put 160 segments. Now, if we compute again the mesh, we see that we have a finer mesh everywhere. So butterfly meshing is not only necessary for the hexahedral algorithm, but it is also a way of locally refining the mesh. Finally, once we are done, we can export the mesh by right-clicking it and go into Export, Med File, and here you can save it wherever you want. Here I'm going to call it mesh1.med. Save it. Thank you for watching this video on Salome. We now have created the geometry and the mesh for the von Karman study. You can find on your screen the second part of the study, where we parameterize Code Saturn and come back to Salome after we run the simulation to visualize the vortices.